Completing the square,
Yeah.
I take the coefficient of x divided by 2, right?
Mm.
Then I need the minus 2.
Mm. Mm. If you have done the completing square wrongly, right, you can actually check it from this step onwards. You can expand it. You can expand this, and then if you can actually expand this and see if you can get back to the original. Okay. Make sense? Make sense to you?
Yeah.
Mm. Mm. Good.
Means
Mm. So in a way, you can see this as this.
yeah.
Mm.
That means the radius is square 3 and
Yeah.
the center is negative 2, 1.
Yeah. Yes.
So that the circle passes through the origin. So I have to equate xy equals to 0, right?
Yes.
That means
No.
2.
Show that the circle passes through. So basically, you just need to show that. So if you have this, the circle, and then you show that it passes through the origin. So what it means is, you put your x equal to 0 and y equals to 0 into this. The equation is valid.
Yeah.
Yeah. Yes.
Okay, 2 square.
If it's valid, that means it passes through the origin. Or in a way, it can be another point like 1 to 2, right?
Yeah.
If this 1 and 2 it makes this valid, then it's the point on the circumference. If it makes this not valid, then that means it's not the point on the circumference. Yeah. Okay.
Okay.
Mm.
Wait, but when I put it as 0, 0, it doesn't add
So
up.
you get 2 square, which is 4. Then you get 1 square, so it's what was this?
1.
Show that the circle passes through the origin. So how? No, right?
No.
Yes, no. So how do you show the circle passes through the origin 0? Interesting.
um,
Okay, first thing first, did you write the thing down correctly or not? Computing square, 4x. Here, 4 minus 4.
oh,
Right?
wait, what? Y.
Because you're completing square x squared plus 4x plus 4, right? This one. Give you this, right? It will be minus 4. Okay? Are you convinced? Are you convinced now?
Yeah.
Okay, good. So in fact, it's just, it should be square root 5. Square. Okay?
Okay. Yeah.
But
So then I get.
just now I asked you to expand and prove. What have you done? Like, it should be 4x plus 4, right? Yeah. What have you done just now?
I didn't times the 2 by 2.
Then what? Okay, that's also one very common. Okay, so it shows what? It shows once you set your mind to that it's very hard to change your mind. Okay, so somehow you will try to you only want to see what you want to see, you know.
Yeah.
Yeah. So yeah. Okay. Never mind. Good. Continue. But anyway, it's good. It's good that you make a mistake and then somehow the part two it doesn't make sense. Then you quickly go back and check. Okay.
Okay.
And did I talk about this format, right? This format equation of the circle is actually uh, using the what? Using the Pythagoras theorem. Did I talk about that?
So why?
Oh,
Is it
okay.
just
So let's talk about it. Okay. So the center in this case is okay. Never mind about this center first. Let's talk about this. This is, let's say, 1 and 1, and then the radius has to be. Never mind. I want to use this. I want to use this example to illustrate to you. Okay. So this one is minus 2 and 1, right? That's the center, right?
yeah?
And then the oh no, center is not this. Sorry. So that's the center. Then probably is this. Then this one is your square root 5. Yeah. Okay. So if you look at it, you can actually see that x minus the 2 is your, this is your a square plus b square equals to c square. Hmm?
Or the triangle to the radius to the circumference and then. I mean no.
So the radius is the radius actually is the longest
Hypotenuse is it?
hypotenuse. Yes.
But then what's the triangle?
Um. Okay. So this is your. So this is your minus 2, and then 1, right? So.
Yeah.
Uh. Hold on. Why minus 1? So this is the origin, right? So you use the origin 0 minus the 2. So that would be this. Okay. So you use 0 minus the 2 is this. Okay. Then 0 minus the 1 is this one, right?
Yeah.
Then this one is equal to the here to here, sorry. Yep, good, done. Yep, I should form the right angle triangle here. This is your square root
Okay.
5. Okay?
Yeah, okay.
Yeah. Okay, so I don't know how this can help you in the future, but I think it's good to know. Okay? Okay, you see Pythagoras theorem in this equation of circle. Okay, good. Next, continue. So the next part is B. Okay, part B.
L1 through O is tangent to both C1 and C2.
I think it's good to sketch it out, huh?
Okay. So this.
This is the center, and then you just. I think you can get the circle from here also. So just get the circle out. Then just move the circle to fit certain thing. Okay. Oh, looks good, right?
So this is -2
and 1. Yeah.
Okay.
Okay, good.
Then we have second circle passes through O and a point A. So the second circle is also like the circle. The line L through O is a tangent to both C1 and C2. So
how do you insert the
circle?
circle? Yeah. Okay, actually, let me just give you a circle and then how you want to put this.
Oh,
no, it's okay. Let me just erase one of them. No, good. I will just erase the one I.
Okay, then
yeah, sure. No problem.
It's like this.
Sure. Go ahead. Actually, I also don't know, but just we need to go with this first, and then we adjust later on. Probably you can use the arrow key to up it up a bit, and then move it up a bit, and then like this, right?
Oh yeah, like that.
Okay, good.
And then there's a line here. There's a tangent to both, right?
Oh, okay, okay.
Tangent to C2 at A is parallel to L1 and cos x-axis at x10. So it should be here. And that should be in it.
So you want to? I thought you need to extend this. I thought you need to extend the number line to 10, right?
10 also.
Right. So this is which is 10. So
where it touches the
cuts the x-axis at x10. The tangent to C2 cut.
C2.
So it should be, you should extend this. I think this is 10. Right? Right?
Yeah.
So this is 10, 0. Yeah.
That means A is here.
So this is line 1. This is line 2, right?
Yeah.
Yeah, good.
What is the significance of OA? Can I say that OA is the
diameter?
Yeah. Isn't it just the diameter?
Yep.
Okay. Equation of the line OA y negative of x. Did they give the equation of the?
I think you can use this one also. Actually, this gradient, this gradient
or the same.
is the same gradient throughout.
Okay, so the gradient that one is 1 minus 0
minus half, yeah. Okay, yeah, good. I think you can easily show this one. I think to find the coordinate of A is also quite easy. You need to form equation 1, equation 2.
m2 equals negative 1, m2 equals 2. Yeah, 2. That means the equation of L2 is y minus 0 20. Yes. And then I equate the 2. So negative half x to x minus 20.
Are your M2 this is your M2?
The gradient, that's the gradient.
Okay, gradient 2. Okay.
20 x 20
Nice.
divided by 2 and a half, which is 8. x8. Oh wait, that's just the x coordinate.
So are you so this is 8, right?
That means the y half negative 4. It's 8 negative 4. That makes sense.
Yeah. Looks good.
Equation of C2. So I have.
You have 0, 0. You have 8 and negative 4.
I find the midpoint, right, to get the center.
I think you can get the radius already.
Radius is just distance, right?
Radius,
but don't I have to find the midpoint first to get the center, then I can find the radius?
So to find the center, which is, you need to use midpoint theorem, I guess.
Yeah.
Yeah, which is 4 and negative 2, right?
Yeah, and then the distance is just Pythagoras theorem.
Oh, yes. Or you can put this into the equation of circle. Or you can use Pythagoras theorem, yes. You see? This is where the Pythagoras theorem comes in, huh? Right? So finally you make use of the Pythagoras theorem. Okay, good. Yeah.
So 20 is equals to 2 root 5.
Yes. Alright, okay, looks good.
Okay, then that's the equation. X minus 4 plus
okay, so that's
5
it.
Plus 2.
Yep, good.
Plus 2 root 5 square. Yeah, it's just square. 2 root 5.
Okay, good. Okay, so actually for questions like this, it's important to sketch it up. So instead of instead of visualizing it from your brain, which takes a lot of workload from your brain, it's better to just put your thoughts onto this whiteboard or on a piece of paper. Then it lessen the workload on your brain, and you should be able to solve it. Okay. Alright, so probably we can do one more question. What's in the next page after this? So let's go back to where's your PDF. Okay, yeah. This is your PDF. No, this is not your PDF. I don't know where's your PDF already. Is this your PDF? Yes. Next one, page 7. Oh, a lot of partial fraction and yeah, partial fraction. And the polynomial.
I don't know how to. I don't know which ones to use.
Use like which one?
The A over. The A over
Hold
B
on,
over
which one you are looking at now?
The partial fractions.
Question 2?
Page,
Are you talking about page 7 and then question 2?
question 3.
Question 3. Okay, good. Let's get this page out. Page 7 out, right?
Yeah.
Okay, let me get it out. Okay, let's move to somewhere pristine. But looks like I don't know where it's untouched.
There's still quite a lot of it on top.
Of course, this universe is infinite.
It is? Oh.
Like infinite means like you can move this page to anywhere. You can zoom in and out. You can to see.
Yeah, but there's a limit. What? Don't you get to the end?
I don't know what's the. Are you talking about this is the limit? No, right? Can you see?
The limit. If you zoom out to 1%, you can.
Okay, let me test. Okay, I'm at 1% now. No, they still allow me to pan to the right.
Oh.
Okay, let's not move too far away from the. I call that the if. Okay, so let's call that the sun. Yeah, let's not move too far away from the sun.
Okay.
Let's go back. Okay, let's go back to the here. Yeah. Okay, let me just zoom in. Okay, let me zoom in to okay 58%. Okay, good. More. Okay, good. So for partial fraction, the first step for partial fraction, you need to see whether it's an improper fraction or not. So for this question, right, I think it's a proper one, right? I think it's a proper one. How do you tell it's a proper one?
The power of x.
Correct. So if this is a proper one, then you don't have to use the long division. Okay? Then you can straight away.
But technically, can't it be improper? Because if
you look at the power, yeah. Like here is the highest power is power 4, here is power 3, so it's proper.
Yeah, but what if there's more?
What do you mean by
like the value when you sub in x?
I don't understand you. I look at this. This shows me the highest power is 3 on top, highest power below is 4, so it's proper.
Okay, but if x is 1, right?
Okay.
The top would be
no, you are talking about okay. So I'm talking about the degree of the x. You are talking about the value.
Yeah, but if the value on top is higher than the value below, wouldn't that be improper?
Yes, you are talking about the value, but very good observation by you. I'm talking about the degree. So over here I'm talking about the degree. I don't care about the value.
Okay.
Okay? But very good thought. Okay? Very good question. Okay? maybe you can post this question to your school teacher and see how your school teacher explains to you. Okay.
Okay.
When I say this is an improper fraction, I'm talking about the degree.
Okay.
All right. Okay. Now, then you don't have to use long division. You just straight away you just So I think you see opportunity to factorize for the below term, right? So you can see x to the power 2. So yeah, x to the power 2 plus 9, right? All right.
Yeah.
And what's next?
You split it into the.
Yeah. Do you have that case 1, 2, 3 with you?
No, I don't have it.
Okay. In fact, you have to memorize them.
Yeah.
Okay. So case 1 is the simple one, ax plus b. So you get a, right? Okay. This is case 1. Case 2, I think is. Okay, sorry, I also can't remember. I've not
Is
done
there
this.
like?
Never mind, let me just get it out.
Okay.
Quickly. This is called partial fraction. I've not done partial fraction for quite some time already, so.
Okay.
I told you, if you ask me to memorize, I can't.
Yeah. But the thing is, I don't understand how when to use the cases.
It's okay. Good. So it's a good practice here. Like, I go just go through this with you one more time. I have. Okay. I hope it's yeah. Oh, it has loaded already, so I don't have to. Okay. So this is
Okay.
case 1, case 2, case 3. Okay. So I think case 1 is pretty straightforward. It's x to the power 1, right?
Yeah.
Case 2 is also quite straightforward. It's something bracket to the power of 2. Okay?
Okay.
Then this is case 3. Okay, so I think, right, you see case 2 here and you see case 3 here.
Okay, but if it was, let's say if it was x squared minus 9.
Then you have to factorize it further. Very good question. So let's say you
So
have
you make
this.
it until the simplest below, then after that you do the thing.
So you are talking about this, right? For the
Yeah.
denominator, so you need to continue. And what you have is this is case 2, this is case 1, this is case 1. Okay?
Okay.
Okay? But we are having case 2 and 3 in this for this, right?
Yeah.
Okay, good then. Good to go. Case 2 is okay, case 2 is this. So just use it, a over x plus x squared b. Done.
Wait, what? How do you?
Huh? So you use this the same thing over the b over the same thing, and then a, then you get it into the degree 1.
Oh, okay. You just reduce the degree. There's
Yeah, so
nothing
you
else.
just see this as x squared. You will have x here and then x squared here.
Okay.
Okay, so that's how you make use of this case 2. Okay, so for case 3, actually this is case 1. Actually, case 3 you focus on this. This is case 3. This is case 1.
So they don't.
So you
So
don't
we're
care
not
about
gonna
this.
use it. Okay.
Okay, so we focus
So
on
what
this
did he
case
put it
3.
together then?
Maybe to confuse you, I don't know. Hey, by the way, this is not the okay. This is I just grabbed the first one from the internet. I don't even know whether this is the standard formula or not. But somehow I recognize what I want to use. They can give me more than I want, but I will just ignore them.
Why did the equal sign they use like the congruent one?
Yeah, lor. Yeah, exactly. So, like I say, this is the first one I grabbed. Is probably is not from your textbook.
Okay.
It's the first one I grab. I type partial fraction, and then this is the one that I think is useful to me to. But anyway, you focus on the. Maybe you should get this ready next time. Okay. Then you share with me what you have in your textbook. All right.
But technically, it should all be the same one, right?
Different countries teach differently, or maybe I mean
But in some math, you have to
variation,
also teach that. Okay.
variations exist. Okay,
Okay.
so this is 3, so it's x squared plus 9. So you have so you cannot use bx and c anymore. You use dx plus e. So far so good. Oh, you still can use c. Sorry.
X plus D, what?
Yeah, you still can use c and d. So far so good.
Yeah.
So in so in so basically you have converted this whole thing into this, and your job is to find out a b c d. Make sense?
Yeah.
So now what you need to do is you need to continue like a. So you short of x, and you short of x squared plus 9. So that's how you get your x squared plus 9. Because I'm going to make it into the same single fraction.
Okay.
Then for this, you short off x squared plus 9 only. Right?
Yeah.
Then for this, is you short off
X square.
x squared. And then after that, you just get it into a single fraction. Then you should get, let me just tidy it up a little bit. So I get ax cubed plus 9ax plus bx squared plus 9b plus cx cubed plus dx squared. Alright? Then by comparison, so you need to compare. But before you do by comparison, I hope you can see you group similar terms. So it's a plus c x to the power 3. This x squared and this x squared is b plus dx squared. Then you have the 9ax. Then you have the, this one is gone. You have the 9b, right? If I'm not wrong. Yeah, 9b. Done. Okay, then you compare this to your this one. Okay, so 6x3 2x squared 6x3. Let me just make it smaller that I can see the entire picture. So it's 6x3. Are you following?
Yeah.
Okay, good. So it's minus 2x squared plus 36x minus 27. Okay, so with this, I think you can find out your b first.
Yep.
So b is negative 3.
Mhm.
A is 4, right?
Yeah.
So if b is negative 3, so plus the d should give you minus 2. So your d is equal to 1, right?
Yeah.
Yep, so a plus c is 6. So a plus c is 6. So 4 plus, so c is equal to 2. Done.
Okay.
Okay, so that's how you put it back into the. So your a is, so basically you put it back here. Your a is equal to 4. Your b is equal to negative 3. Actually, I zoom out, so then I can see more stuff. So c is equal to 2. D is equal to 1. That's it. Yes. So is it in that format already? What the question 1 actually?
This
Expressed in partial
question.
fraction. Yep, so this is the partial
Okay.
fraction.
Okay. Then
Okay.
when it's improper, I have to do long division by.
Yep. Long division, then you get so this is like, okay, this one is improper, so that's why they guide you a little bit. This one,
Yeah.
they guide you a little bit.
Well, why do they? Can't we find this ourselves?
Oh, okay, then if you want to do this, is just do this for
It's
x3
long divide. Then after
long
that,
division.
the remainder is the one that we have to do a partial fraction on, right?
Okay, so I don't know how I don't know how your school teaches you, but maybe I should share with you my approach. By the way, my approach is always a modified approach from my experience. Okay, so so you put a 4x, so it's 4x3, right? Help me out if I make a mistake somewhere.
Okay.
Well, my brain is a bit exhausted already.
Okay.
Okay, so minus, this minus x. Minus 1 is plus, so it's plus x. Right? And minus 1.
Wait, minus 8x plus 8x would be 0.
Oh,
Right?
thanks. Very good. Okay.
Okay.
Then, can I continue? Yep, minus 1, right? Okay, good. So it's minus x square minus x plus 2 gone x minus 1 minus 2 minus 3. Okay, good. Done. So,
Yep.
with this, let me just zoom in. So your this 4x3 plus 3x squared minus 4x minus 1, right? So how I read this is this. I give myself a simple example. I put a 4, I get 8 is 1. So 9 is equal to 2 times 4 plus 1. So therefore my nine is this whole thing. So this whole thing is equal to this is my divisor. So x squared plus x minus 2 times this quotient plus the x minus 3. So far so good?
Yeah.
Let me zoom in. Okay, but the question wants what? The question wants this whole thing divided by the x squared plus x minus 2, right? The question wants
Yeah.
this one, right? So therefore you
Yep.
need to divide by the x squared plus x minus 2. This one also must x squared plus x minus 2. Then you can see that this one cancel each other. So you end up with the 4x minus 1 and then plus the x minus 3 x squared plus x minus 2. So you have gotten it into that format already.
Then isn't that just the answer?
Maybe you just by comparison you get your a equals
Yeah.
to
You get
4,
everything
then
you
your b
do.
equals to negative something, then yeah, yes. Okay?
Oh, is that how we're supposed to do it?
Then your c is equal to negative 3. Okay?
Okay. Okay.
Okay? So
Yeah.
so I don't know whether your school teach you this way or not.
Yeah. That's how we long divide.
Okay, good.
The way
But
that you did.
I like to teach students, if you don't know how to express it, right, just make use of this simple example.
Okay.
Mm. And then yes, so that's how you get your ABC. Okay, good.
Okay.
So yeah, that's it for today.
Okay.
All right. Okay, so probably next week probably we want to do a bit on we want to spend some time on polynomial.
Okay.
Okay. Uh, and no trigonometry anymore. Okay,
Okay.
too much of
Yeah.
trigonometry already.
Okay.
I think you are pretty good already these days, right? The
Yeah. Okay.
identities part, the solving the angle part, and okay.
Okay.
Okay, good. So any other question?
No.
Okay, good. Then yeah. So enjoy your weekend ahead. Bye bye.
Okay. Thank you.
Bye
Bye.
bye.